Hey everyone, it's Matt here with Nightrun Studio, and in our last video we got our first state set up for our NPC system. Our NPC can now patrol around between as many points as we want, pausing each time he reaches one, and we've added animations and flipping. In this next video we're going to add another state, the wander state. Here we'll be able to set an area in which our NPC will wander freely, pausing whenever he reaches the outside edge of this rectangle, and also adjusting his course each time he hits a collider. That's where we're headed in this video. Let's get started. Alright, the very first thing we're going to need to do is to create a new C# script, and we'll call this one NPC Wander. We can begin by getting rid of our start and update method, and we're going to create our wander area first of all. So let's just make a header to keep all these variables organized. We'll call this one wander area. And then we'll start with two floats, one for our wander width and another for the wander height. I'm going to initialize both of these to 5 to start, but we can change them in the inspector later. I'm also going to make a public vector2 called starting position. Now at this point, we're just going to make it so we can visualize this. So I'm going to create a public void on draw gizmo selected. And here we're just going to start by defining a color for our gizmo. I'm going to make mine red. And then we'll draw a wire cube. And here we're just going to punch in a couple of coordinates, our starting position, which will be the center point for this cube, or rectangle in our case. And now we're just going to create a new vector 3, which will describe that rectangle. This will be as wide as our wander width, as tall as our wander height, and we'll just put a 0 for the Z value as we are working in 2D here. Back in Unity now, I'm just going to click on the parent of my NPC where we have our patrol script. I'm going to minimize that, add the wander script, and here I'm also just going to make it so that our patrol script is no longer enabled. Eventually we'll add a controller script that will toggle different states, but we'll leave that for another video. At this point, I'm just going to put a starting position, which will be roughly where my NPC is. So I'll just go with like -30 and 25. And we might actually just enlarge this wander area a tiny bit as well. All right, now that we've got it visualized, we want to actually get this NPC moving. Now to make any sort of movement happen, we are going to need our rigid body. So I'll make a private reference. We'll call this RB. And the reason we're making this private is just to keep our inspector nice and clean. However, this does mean that in a wake, we're going to need to find it. We can do this by just saying that our RB is equal to, and here we'll do a get component call, and in this case, we're looking for a rigid body 2D. At this point, I will add back my update method, oops, and here we're just going to set velocity the way we usually do with rb.velocity is equal to direction times speed. Though of course, neither of those variables currently exists, so let's fix that. First off, let's come up top here where we can just make a public float called speed. Now in our case, for our direction, what we're going to do is we're going to select targets on the outside of this rectangle, and then we'll figure out what the direction is in order for our player to get there and send him in that direction. Now to make this happen, we're going to need to keep track of our target. So let's make a vector2 variable for that. Then down in update, we can use our target to help us find the direction. So we'll make a local vector2 direction variable here. And it's just going to be equal to our target minus the NPC's transform.position. Now it doesn't like this at first, and if I mouse over, you can just see that's because we're trying to subtract a vector 2 and a vector 3. So here I'll just cast my transform position as a vector 2, which essentially will just drop off the Z value, which we aren't using anyways. Now both target and transform position will render as vector 2s. One other thing I'm going to do, and I explained this in more detail in the last video, is just normalize this vector so that the NPC doesn't move faster when he's far away from his target and then gets slower as he gets closer. All right, for now we're just going to set him as a position for testing. I'm going to go with just -25 and 3, which should be right and up a little bit. When we get in the game, then you can see that he does in fact move in that direction. And when I click on the scene view, we can see that he's just kind of gyrating there. And that's just because he's trying to get to the position, but he's already there. All right, we've got some work to do. So up until now, we've been setting this target manually, but we're actually going to calculate it. And we want our NPC to do this every time we turn this state on, not just at the start of the game. And so here we're just going to say that our target is equal to, and here we'll call a new method we're going to create called getRandomTarget. We can then come down below and actually create this method. So we'll make a private void getRandomTarget. Though in fact, this is actually going to return a value. We want this method to always give us a vector 2, so let's make it a private vector 2. Now this is going to be the most challenging part of this entire video, is we've got a fair bit of work to do here to do this calculation. So essentially we're going to try to pick different points that are on the outside of our rectangle. To do this, we need a couple of variables. So first we're going to make a float called half width. This is just going to take half of our rectangle, and that's just because If we're on the left side, we're going to be halfway from the center point, and the right side is halfway in the other direction, and so we're going to be using our halves a lot. Now, once we've stored those values, we also want to just make another one. This is going to be an integer called edge. Now, our rectangle has 4 edges, and so here we're going to make a random dot range between 0 and 4. This is non-inclusive of 4, so it will always return either a 0, 1, 2, or 3. All right, with those variables created, now we actually will calculate where we're going. So to do this, we're going to return, meaning the result of the calculation we're about to do will get popped out, and that will be a vector 2. And here we're going to use a edge switch. Now, edge just refers to that variable we just create. And a switch is sort of like an if statement. It's just a little more elegant, and it takes up less space on the screen. And so our switch here is edge, and so depending on which edge is chosen, 0, 1, 2, or 3, we'll run a different line of logic. So if a 0 is chosen, then this method is going to return a vector, and here's how we're going to calculate it. And so for the x value, our vector is just going to take our starting position and subtract half of the width. This will get us all the way to the left side of the rectangle. Then we need to pick a random point along that line to be our actual destination. So for this, we'll just make a random range. And here we're going to start with our starting y position, which is again the center of the rectangle. And we're just going to subtract half of the height. That's our lowest point that it could possibly be. And then we'll just use starting position.y and add half of the height, which would be the highest point it could be. So we'll get the most leftmost point of the rectangle, and it'll just pick a random point somewhere along that line. We're then essentially just going to repeat this logic for our right side. And here we just need to make sure that we change so that rather than subtracting the half width, we add it. That way we end up on the right side. And now we can do our top and bottom positions as well. Here we're going to need to swap our logic a little bit, as the x is going to be the random part. It could be a random point anywhere from the leftmost to the rightmost point, and we do this by using our x starting position and subtracting the half width, though here I realized that I used a lowercase on my w, so I'm just going to change that for each instance. And the other part of our random will be our starting position x plus the half width. And then at that point, we're going to use our starting position.y, and we'll just subtract the half height this time. That will return us the bottommost point on our rectangle. And now we're ready to do the top. So for this, I'm just going to copy that last line, and our x value can stay the same, picking anywhere from the left to rightmost points, but we need to then change it so that our y value is the starting position plus half height, so that it's somewhere along the top of the rectangle. Okay, that was a little ridiculous. We can add a semicolon down at the bottom here, and now on enable, we'll just get a random target calculated, and that's now going to be how we calculate our direction. Now, if we were to stop here, you can see we're getting a warning that we have not accounted for all possible results in our switch statement. We actually have, but best practice is always to have a default. So a piece of logic that will run if some number gets rolled that we don't have a result for. So in this case, instead of a 3, I'm just going to put an underscore. All right, after all that hard work, we haven't accomplished much. He does move to a random edge, and if I pull him back away, you can see that he continues to move to that edge. However, this really doesn't look like much. We really want to have it so that when he gets to the edge, he selects a new position to go to. Now, changing his destination is quite easily done. Here, just before we set our direction and update, we're going to use an if statement, and here we'll use a helper method from Unity called vector2.distance. We can just put in 2 coordinates here. We'll use our transform or NPC's current position and his target's position. And essentially, if the distance between them is ever very small, we'll say less than 0.1, then we just want our target to become a new random target. This creates a significant improvement as now he moves around, and each time that he hits a edge, he just picks a new target. Not bad, but I'd like to add some pausing as well as animation. We'll start with some variables here. The first will be a public float, which will just be our pause duration, and I'm going to set mine to 1 second for now, though we can change it in the inspector if we like. I'm also going to make a private bool called isPaused, and this will just be a flag that tracks whether we are in a paused state or not. Now in update, we can just set things up so that if we are in a paused state, we return, meaning we don't execute any of our movement logic. However, I'm just going to put this in brackets as I don't want our NPC to continue drifting off into space while paused. I want him to stop. So here we'll just set his rigid body's velocity to be equal to a vector2 of 0, then call return so that he doesn't execute any more logic in our update method. Now, however, we need a way to actually set when we are paused, and we actually want to do the pausing. For this, we're going to create a new method, although Because we're wanting to add a pause here, we're actually going to make a coroutine rather than a method. So instead of a private void method, we're going to make an IEnumerator, which we'll call pause and pick new direction. The first thing we'll do here is set our isPaused flag to be true, and then we're going to initiate our pause. We can do this by typing yield return new wait for seconds and just put our pause duration in here. The beauty of a coroutine is that it can just be put on hold until it executes any further. Once that pause is done, however, we're going to want to get a new target, so we'll make our target equal to a random target. And at this point, we can just make isPaused equal false, meaning update will now be allowed to run, but it will be going towards that new target. The other thing we want to do here is anytime we reach our target, rather than immediately setting a new one, we're just going to call this method pause and pick new destination so that he halts first, then goes in a new direction. When we get in game, we can see that's working quite nicely. He's pausing each time he reaches the edge and then moving on. Next though, I'd like to make this look a little better, so let's add some animation. To do this, we'll start by creating a private animator reference called anim. And just like we did with our rigid body, we're going to get this in awake by going anim equals. However, this time we can't use getComponent as the animator isn't on this game object, it's in a child object. So here we'll just use getComponent in children and look for the animator. Now playing the animations is quite simple. We just come into our coroutine, and right after we set isPaused to true, we'll just tell our anim that it needs to play idle. Now here, if we pop in the game, you can see in our animator that we're talking about the state names here, idle and walk, not the names of animations themselves, just these states. Now in our coroutine, immediately after we unpause, we'll just tell our anim that it should then play the walk animation. Now before we go in and test this, I'm also just going to add some flipping back and forth. However, I'm noticing that my update method is starting to get a little bit full, and I like to keep our concerns separate here. So I'm actually just going to create a private void move method here and drop all of my movement logic in there. We can then call move from update right after we've checked if we've reached our destination or not. Now in order to have our flipping work, we're going to come down below where we set our direction. Then we're just going to do a little check. Here we just want to see if our direction's x value is greater than 0, meaning we're oriented or trying to go towards the right, but our transform local scale's x is less than 0, meaning we're flipped toward the left. Now if that's true, or if our direction x is less than 0, meaning our target is to our left, but our transform local scale x is greater than 0, meaning we're currently flipped toward the right, we also have a problem. So if either of those things are true, we need to set a new transform.local scale. We'll do this by setting it to a new vector 3, and here we just type in our transform local scale x's current value and multiply it by -1. Then for the y and the z, we'll just go transform.localScale y and transform.localScale z so that they stay the same. With that done, we've now got our animations working quite nicely. He's pausing, he's flipping, everything's great, except that at the beginning he wasn't actually playing his animation for that very first round. Now the reason for that is just that on enable, we're automatically setting our random target, which doesn't affect our animations. So instead, let's start the coroutine, pause, and pick new destination, which will pick a destination and start up our animations. Finally, let's just quickly set up our logic so that if we collide with any objects while moving around, we just pause and then pick a different direction. To do this, we're going to use our onCollisionEnterToD method. And essentially just if he collides with anything, we're just going to call that coroutine, pause, and pick new direction. All right, with that done, I'm just going to quickly resize my wander area here so that you can kind of see it in action. I'm going to make it much wider and larger so there's some obstacles in the way, and we'll see how he handles it. All right, and when I get in the game, you can see that he is in fact changing positions each time he hits the outside edge. He's moving up into some corners, and when he hits something like a tree, he just automatically pauses and reroutes himself. All right, that's working quite nicely. Hope you found this one helpful. In the future, we're going to make it so that we have a controller that decides which state to be in at any given time so we can move back and forth. But before we do that, I just want to get another state set in here. And so we're going to be adding some dialogue in the upcoming video. Hope to see you in that one. Until that time though, this is Matt with Nightrun Studio. Cheers.